Question number 7 is the algebra equivalent of divisibility tests. So, if you want to know whether the 2001 is divisible by 3, you can do the division and hope you get a remainder of 0. You get 667 up there, I think. Or you can just use the test. To work out if a number is divisible by 3, just add up the digits and see if that's divisible by 3. These add up to 3. 3 is divisible by 3. So therefore the whole number is divisible by 3. The algebra equivalent of that, when you're trying to decide if that division will work out or not, use the factor theorem. Ask when that's 0. That's 0 when x equals 2. Substitute 2 for 0 there, for x, sorry. And ask, do you get 0? So that's 8 minus 14 plus 6 equals 0. Answer is yes, so x minus 2 is a factor. What about x plus 1? When is that 0? X equals negative 1. Substitute negative 1 in. Is that 0? Negative 1 plus 7 plus 6 is equal to 12, which is not 0. So x plus 1 is not a factor. In part B, we now have to factorize the expression. When you succeed in doing a division, you get to write the dividend as a product of the divisor and the quotient. So 2001 equals 3 times 667. So for us, we get to write x cubed minus 7x plus 6 equals x minus 2 times something. Now you can tell that the thing on the end will be negative 3 because only that could work with the negative 2 to produce a 6. But what would those be? Well, just like I did up here, or just like I hinted at up here, just do the division. Left a gap there because you need everything to nicely line up. That divided by that is x squared. That times that is x cubed. That times that is negative 2x squared. That minus that is blank. That minus that is 2x squared. That divided by that is... So I don't know why I didn't write the answer there. That divided by that is 2x. And if that were done, that has to be the 2x. Now, can that be further factorized? One way to work out if it's worth your while factorizing that is just to work out what would be under the square root symbol if you use the quadratic formula. If it's going to factorize nicely, you need that to be a square number. The term for that, by the way, is the discriminant, or often indicated by that triangle. So b squared is 4 minus 4 times a times c, so that's 16. That is a square number. So this is worth factorizing, and in fact it's pretty easy to factorize. Just lay down double brackets. I think that does the trick. That times that is negative 3, that's 3x, that's negative 1x, they combine to give 2x, it's good to go. So that's the answer to part B, Roman numeral 1. Roman numeral part 2 sticks with 0 there and asks you to solve. Products coming out to be 0 is very special. That can't happen unless the ingredient elements of the product are 0. So x minus 2 equals 0 leads to x equals 2. X plus 3 equals 0. Solve that, you get x equals negative 3. And the final one is x equals 1. So there are our answers there. So that's question 7. Question number 8. Linear programming. The method for this is to write the inequalities with equal signs initially and graph them. So how do you graph them? Those ones are very simple. That's the x-axis. I'm dotting that because it tells us to shade what's not required. The line counts, so therefore the line is required, therefore dot it to show that you're not shading it. Dotting a line is the way that you show that you're not shading a line. That's x equals 0. Do these with quick tables. If x equals 0, y equals 12. If y equals 0, x equals 4. I'm going to do this properly. Put it all up. So that's that one. Now what about this one? If x equals 0, y equals 10. And if y equals 0, x equals 6. It's important to get these proportions right. I've been a bit sloppy here. Really should get out a ruler and make sure that whatever scale it does, you have that enables that to be 4 would also enable that to be 6. Similarly, the ratio of that to that needs to be 5 to 1. If you're not careful with those scales, then you'll make a mistake in the next part, possibly. Because, oh, by the way, sorry, we need to shade things now. So let's restore these to what they were. We want that to be greater than 30. We want that to be greater than 12. We want that to be greater than 0. We want that to be greater than 0. So in other words, we like the higher side of the x-axis. We like the right side of the y-axis. For these, I'm going to use a test point. 0, 0 is a classic. If you put a 0 where x is and a 0 where y is, you get 0, which is greater than 12, which is not true. So we do not dig this side of that line, in other words, the side that has 0. What if you put a 0 there? You certainly, 0, 0, you certainly don't get greater than 30, so we do not dig that side either. So we don't want any of this. So everything over there is shaded, everything under here is shaded, everything under there is shaded, everything under here is shaded. So that's Roman numeral part 1. Roman numeral part 2 is to find out the minimum value of this. So let's just pretend it's equal to 10. Let's actually, I'm going to use numbers that are factors of that. X equals 12. So I'm going to graph this. If x equals 0, then y equals 12. If y equals 0, then x equals 6. So this is our grades line here. And by coincidence, I often do this in a different colour. And the idea is that when you draw that, but being very careful not to twist it so that you lose the gradient, you either bring that down if you're trying to find a maximum, or bring that up until you find a minimum. Now I make the grace point there, which means I must have messed up my gradients because it reckons that the grace point is there. I'll show why that would be. My mistake now. If x equals 0, y is certainly 12. If y equals 0, x equals 2. So now as you bring that over, it touches there first, so that's the grace point. Sometimes you need to work out the coordinates of that point by simultaneous equations, as I would have had to if that was the grace point, but here it's clear that it's 12, 0, 12. So just substitute that in there. Remember that was just a fake value. So 6 times 0 plus 12 equals 12, and that is our minimum point. Question number 9 is an integration question because they give you the bottom row of a multiple choice box and they ask you to come up with the row above. So what would lead to that upon differentiation? That would, because that would come out the front multiplying by the hidden 1. That will be reduced to 2. Same reason for that, and that will be a 4x. There would be a plus c. But we're given the additional clue that it goes through 2, 2. So when you put a 2x's, so I'm doing now, a 2 should spit out for where y is. Just simplify this. C equals negative 10. So that place where I should have put a c, this should now be a minus 10. And that's the answer. So that's question number 9. Question number 10. We're given that sine theta equals 2/5. Now this is like a trig equation, so you can actually work out what sine is if you want. You just go shift sine 2/5. But let's use the calculator, and since we're asked to find an exact value for cos theta, it's better not to do that. And also we're actually told to use this. It's actually really straightforward. It's only worth 3 marks. So instead of sine, write 2/5. So therefore cos theta was plus or minus the square root of 21 over 5. Square at the top, square at the bottom. But because theta was acute, it's got to be around there. All three of sine, cos and tan are positive there, so cos certainly will be. And so that's the final answer. That's question number 10. Question number 11. This is probability, so it's going to be those tree things. They're in boxes of 6, and each egg has a probability of being cracked of 1 in 20. The fact that it's independent of the other eggs just enables you to do this situation. We've got 6 eggs, that's why I've got 1, 2, 3, 4, 5, 6 stages of forking. Find the probability that there'll be no. So the question is it cracked or not? Yes, no, etc. So up here we're going to have yes, 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 yes. Down here we're going to have no, 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 no. And I think 64 things in this summary if we did it out fully. Where do I get that from? It's 2 to the power of 6. Now, what'll this one be? That's no cracked eggs. That's 19 over 20, I think, is the probability for not being cracked. So 19 over 20 to the power of 6. So just this times this times this times this times this. That's Roman numeral part 1. In one box, there is exactly 1 cracked egg. So that's like no, 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 yes, or no, 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 yes, no, no. Now how many of those would there be in the summary? The reason why that's interesting to me is that the probability attached to each of those will be 19 over 20 to the power of 5 times 1 over 20 to the power of 1. You often use the binomial coefficients to predict how many of those there will be, so you can multiply by that. But it's pretty clear that there's only 6 ways to place a y amongst 5 n's, so it's just straightforward 6. So that's the answer to Roman numeral part 2 when you pump that through a calculator. Apparently for that you get 0.735. For that you get 0.232. Now, Next part. Obviously if there's cracking, they could be checked as follows. He takes a box at random from the delivery. Remember there's 6 in a box. So, stage 1 is, are there any? The answer is no, that's the end of the matter. And the summary would be just a straightforward no, and that would be accept. And we already know that the probability of there being none is 0.73, etc. You can use your memory button of your calculator, by the way, to store these in so that you don't have to type them in laboriously later. Alternatively, if there is at least one, well, it's not just a matter of one, it's yes. So I'm going to change this to how many. 3 cases. There's 0, there's 1, or there's more than 1. The 0 case, we've already got that. That's 0.735. Just this probability. Because there's nothing over here to multiply it by. If there's exactly 1, we'll deal with that in a second. If there's more than 1, then it's just straightforward reject. What's the probability of there being more than 1? It's 1 minus the probability of these two. So 1 minus 0.735 minus 0.232. Now what about the 1? That's where it forks again. So either it has none or one or more. I'm going to show that should be 2 plus. It's just my way of indicating 2 or more. So that should be 1 plus. The probability of 1 or more is 1 minus the probability of none. The probability of none, we've already got that. That's 0.735. So on the summary, so the summary is none, 1, then none, 1, then 1 or more, and then 2 plus just straight out at the beginning when we first check a box. So what's the probability that the batch is rejected? It's this one, and so hold on, sorry, it's this one and this one. So it's 1 minus 0.735 minus 0.732, that's this, plus the probability for these, so that's 1 minus 0.735 times whatever that was. What's the probability of is exactly 1? 0.232. So I'll say it again, that comes from this element of the summary, and this comes from that element of the summary. You just multiply the probabilities along the branches. I'm just going to check the mark scheme. Yeah, you pump that through a calculator, you get an answer of 0.0943. It's 4 decimal places, and that's your answer. Okay, question 12. We've got 2 cars, point O, moving away from point O, straight road. Apparently they're at rest to begin with. Doesn't actually say they're going in the same direction. Have to keep an open mind on that. It could be that A is going that way, B is going that way. But anyway, let's start. Part A. Part A has constant acceleration, so we can use suvat for car A. You don't have to though. But we certainly can, and we're told to express the displacement as a function of t. That one certainly expresses displacement as a function of t. U is 0 because it says that it's at rest initially, and acceleration is 2, so in fact that's your answer there. S equals t squared. Now, part B. Car B does not move with constant acceleration. It moves with variable acceleration given by this rule. How do we get the displacement with this? Not with SUVAT, but rather with the 3-line multiple choice box. So half t plus 1 will become v equals a quarter t squared plus t plus c. And by the way, I can null that c straight away. We were said that the velocity initially was rest, so if you put a t equals 0 there, you should get a v equals 0 there, so that means that c plus c must be 0. And finally, integrate this, you get that. And I should put a plus c there, but if we just make the reference point where it starts from, then when you put t equals 0, then the displacement will be 0 because it hasn't moved yet, so it can't have been displaced anything. So in fact that's an answer there. Find the time at which the cars are the same distance. So when does t squared equal a 12th t cubed plus half t squared? I know distance isn't the same as displacement, but if everything's nice and simple, if nothing turns around, then displacement will by coincidence be the same as distance. So anyway, double everything. Oh no, wait on, times everything by 12 will be quicker. So they're certainly the same distance away initially, so t equals 0 or t equals 6. So that's the time where they're the same distance. I've just answered part C, Roman numeral 1. And how much have they travelled at that time? Well, if you put a t equals 6 in there, you get 4. So if they've travelled the same distance, then that will be 4 each. Oh, wait on. Misuse that. That should be 36. Should get the same if you put a 6 in there. That's 6 cubed. So that's 6 squared divided by 2, just cancelling a 6 there. So that's 18 plus 18, yeah, so it's 36 in each case. And draw a sketch of the velocity of each car. So we want that, and we also want that. 2t is that. And how about the graph for this? Well, that's a parabola, a bucket up parabola, has a x-intercepts of 0 and 10 and -4, 0 and -4. And we know eventually that will catch up. Can't have negative times, so I'm going to cut all that. Now, where do they meet? I think it's probably a good idea to nail down what that is. I'll just see if it's quick to find that out. 2t equals a quarter. So t equals 4. Yeah, t equals 4. And so that will be a height of 8. So that's our graph there. So that's car A, and that's car B.